Good morning, everyone. In the last class, we had discussed about the fuse, which is used as a protective device for a power system network. And we had seen various types of fuses like a rewirable fuse and a HRC fuse, a KitKat fuse. Now today we will discuss about the circuit breaker, which is also one of the protective device for the power system network. So these are the topics which we are going to discuss today's class. One is introduction to the circuit breaker, operation, production of the arc, extension of the arc. So basically, a circuit breaker is a piece of equipment which either make the circuit or break the circuit manually or by remote control under normal operating conditions. And under faulty conditions, a circuit breaker will break the circuit automatically. And once the fault is over, we need to again make the power system intact. So that means it can make the circuit either manually or by remote control under fault conditions. So then we'll see about what are the parts of the circuit breaker and how the circuit breaker will operate. The circuit breaker consists of fixed and moving contacts as shown in this figure. So this is the fixed contact and this is the moving contact. And under normal conditions, the fixed contact will be intact with this movable contact. And whenever the fault occurs, the movable contact will move away in this direction from the fixed contact, thereby breaking the circuit. Actually, the power flow will be from, this is the input terminal, and it goes via this bimetallic strip. There is a point latch, and this is the operating coil, or otherwise called as the trip coil, and through this it goes to the fixed contact, movable contact, and then it comes to the fixed contact, and this is the output lead. So that means the input terminal is this. For a layman, you can say this, you have to use this as the input and this is the output terminal. So that means what? In the case of a fuse, you do have one terminal at this side and the other terminal at this side. You are going to rewire this. Similar is the case with circuit breaker, but there is a different mechanism. In the case of a fuse, you will be having a fuse material between these two, whereas in the case of a circuit breaker, you do have a breaking mechanism employed instead of a rewirable fuse. So when a fault occurs in a circuit, the trip coils of the circuit breaker get energized, and this trip coil will get energized, and this will shunt away this particular lever, that is the trip circuit, and under that is faulty conditions, it gets stripped. The position of this will be in this direction here. Next, so during the breaking operation, what will happen? So whenever we start moving away the movable contact from the fixed contact, because we want to break the circuit under faulty conditions, the contacts of the breaker start separating. You are creating a physical gap between them. So whenever you start creating a gap, the resistance will increase. The reason being is you are creating a open circuit. So that means this resistance between the contacts starts increasing. Whenever this resistance increases, the current under faulty conditions being very large, and the resistance are also is large, then I square R losses will be more, which increase the heat. This heat increases the energy of the electrons in the contact areas and also ionizes the particles that are surrounding these particular circuit, that is the contacts, and it maintains the current through this ionized particles. So that means though the contacts are physically separated, but electrically they are intact with each other. and this flow of charged particles from one contact to another contact is called as an arc. Due to these charged particles, the arc continues even if the breaker contacts are separated. So now we'll see the reason for this arc formation. So whenever you start separating this arc, these contacts, though the distance between these contacts is that is the voltage that appears between this is very small, but the distance between these contacts being still smaller, so a large voltage gradient will appear across this. This is sufficient to cause deionization of the air or any medium, whatever it is, surrounding this particular place. So thereby the arc is being formed between this. So that means these contacts though appear to be physically separated, but if you look here, they are electrically intact with each other. So now this arc has to be extinguished. So if this arc is not extinguished, the very purpose of the circuit breaker is not served. So that means we need to make this arc to extinct. So that means it has to be suppressed. So how to suppress this arc? There are two methods of suppressing this arc. One is high resistance method and is lower resistance method. In the case of high resistance method, what we do is we increase the resistance of the arc. So when we increase the resistance of the arc, the potential gradient that is there across this is not able to maintain, that is, it's not able to break this gap. So thereby the arc will get suppressed. So that means you have to increase the resistance of the arc. Whereas in the case of low resistance method, what we do is instead of we suppress this arc by deionization. That means we create a medium, or we force air or SF6 gas or some other material that is medium. Thereby the arc will be deionized, that is the ionized particles will get deionized. So now I will show you how this arc, one method, how this arc resistance can be increased. So if you see here in this operation, this is the arc runner. So the arc will move like this into this runner, and this is the arc path like this. So whenever the arc moves like this, what will happen? The length of the arc is increasing. Earlier the arc is restricted only to this place between these two contacts. Now if you blow air across this, then this arc will be increased in length, and moreover the size of the arc will get reduced. That is, the area of cross section of the arc will get reduced. So as all of us know that R is equal to rho L by A, then rho remaining the constant, L, the length of the arc is increased and the area of the cross section of the arc has been decreased. So that means we had increased the resistance of the arc. So that means whenever the arc resistance increases, this arc starts splitting. So that's why this is called as arc splitter. Once the arc splits, if you see that it is more open circuits will be formed, that is the arc will be suppressed. So in the next class we will see various types of circuit breakers depending upon the medium which we create to deionize this particular arc. So thank you.